With a regression, when you want to look at how changes in one variable or more variables cause change or changes in other variables, then you are talking about regression. So most often when you set your objective, and the objective is to look at for the effect or influence or impact of one factor on the other, then the regression becomes the obvious kind of test that you have to perform. The regression comes in so many forms. You have the simple regression, you have the multiple regression, you have the simple regression, you have the multiple regression, you also have the hierarchical multiple regression, and then you have the logistic regression. There are other host of them. So, but under this context, we study about the three of them: the simple regression, we look at the multiple regression, hierarchical, multiple regression, and then logistics. Okay. We look at these three types of regression. Now, regression, these approaches are all parametric methods. Parametric. So if they are parametric, it means that they come with some assumptions, right? Yeah. Under correlation, we didn't mention some of the assumptions, but I suppose you already know some of them. The sample size should be adequate and representative. The dependent variable should be normally distributed. There shouldn't be the sample should be sampled based on probability sampling. These are some of the few assumptions that you can talk about with the correlation. Now, these assumptions also work here, but we have other host of assumptions as well that we can consider. Okay, so there should be a linear relationship. Okay, there should be a linear relationship between the dependent and the independent variable. So linearity is the key assumptions under regression. There shouldn't be autocorrelation. There should not be autocorrelation. There should not be autocorrelation. So autocorrelation is measured by what we call Darwin-Watson. And if you get, there's a threshold for Darwin-Watson, you should have between 1.5 to 2.5. If your Darwin-Watson score falls within this range, then we say that there's no autocorrelation or there's no serial correlation. Because if you want to look at the effect of one factor on the other, and there's a natural relationship that already exists, why do you have to go on and still look at for the impact? Okay. So there shouldn't be that kind of auto or serial relationship existing between the dependent and the independent variable. So you use Darwin-Watson to check that. So if the threshold falls between 1.5 and 2.5, then we say that there is no autocorrelation. Okay. Another term for autocorrelation is what we call serial correlation. Okay. Another important assumption that you have to test under the multiple regression is that there should not be multicollinearity. There should not be what? Multicollinearity. Collinearity. And the multicollinearity is measured by what we call the VIF, variance inflation factor. Okay. Multicollinearity is tested by the VIF. Okay. Now, when you get your VIF, we expect that the VIF should be less than, it depends, okay? Some say that it should be less than 3.3. Some also say it should be less than 5, whilst others say that it should be less than 10. You understand? Okay. So it depends on the threshold that you are getting, 3.3, 5, or what? 10. That is what they are saying. So when you get your VIF like this, check if it is within this threshold, the one that is familiar or supporting yours that you quote to really justify its inclusion in your research. Okay, so that is what we call multiple correlation. Multiple regression. Some of the assumptions that we have mentioned. Okay, we have other hosts of things, the model simplicity and the rest. There should not be singularity and all those things. All those things are there. We will test them with the statistical software. Okay, so these are some of the assumptions. Now, when you compute for your multiple regression or simple regression, there are some results that will come. I just want us to look at the most significant ones. We have a host of other results, but I want us to concentrate on the significant ones that will really make it easier for us to appreciate. There's a table called model summary. Model summary. Model summary. Model summary. When you pick your model summary, there are at least 3 things that you have to look out for. Okay? The first thing that you have to look out for in your model summary is what we call joint correlation. Joint correlation. And we will see why it is called joint. Okay? Joint correlation. It is represented by R. It is represented by R. Most of the time, big R, capital R. Okay? Joint correlation. Another thing is what we call R squared. R squared. And the R squared is called the coefficient of determination. Coefficient of determination. Coefficient of determination. Which measures, for the joint correlation, it measures the relationship between the predictors on one hand. Listen carefully. The relationship between the predictors on one hand and the dependent variable, okay, on the other hand. For the joint correlation, it measures the relationship between the predictors on one hand and the dependent variable on the other hand, okay? So it's a collective correlation. It's not a singular kind of correlation. Okay? Then we also have the R squared. The R squared talks about the percentage change in the dependent variable that can be caused by changes in the predictors. Okay? The R squared.
So measure the percentage.
The percentage change in the dependent variable as accounted for by changes in the independent variables or predictors as accounted for.
Independent variables.
Yes. Then, as usual, you check your waxing. In fact, it should have been the first thing that we have. It should have been the first thing to talk about, okay? Waxing. And I told you that it should fall between what? 1.5 to 1.5. Test for autocorrelation or serial correlation. Okay. So these are the 3 key issues that you have to consider in your model summary. Then we go to a table called ANOVA. ANOVA. The ANOVA tests the level of significance. The ANOVA tests the level of significance. Test the level of significance of the R squared. Okay? It tests the level of significance of the R squared. It also gives indication if any of the independent variable is a significant predictor. It also gives indication if any of the independent variables is a significant predictor. So it does not only help us to substantiate the claim about the change in the dependent variable, it also gives indication that at least one of the predictors is making significant contribution. Okay, that is what it does. And what measure do we have to look out for? if you look at that table, at the extreme end, there's a place called sick. Sick. And the sick should be less than or equal to what? 5%. For it to be significant, as we discussed earlier. Is that not it? Yeah. Because we have confidence interval 95%. So margin of error should be what? 5%. So when you add them, it should be less than or equal to what? 1 or 100%. You get it?
Okay,
Yeah. So whenever your sick value is above this point, 5%, it means that your result is not significant. Now you got it by what? Chance. Got the result by chance. I told you it doesn't mean that the result is no good though.
Yeah, correct.
You got it by what? Chance. That's all. So that is what you have to look out for under the ANOVA.
Okay.
Under the
ANOVA table.
Yeah, under the. So the last table you have to look out for is what we call coefficients.
So that also under the ANOVA table.
Coefficients. Yeah, after the ANOVA table, we go to another table called coefficients. And the table called the coefficients talks about the contribution of the predictors. Contributions of the independent variables. Independent variables to the R square, okay? To the R square that we have recorded. So given the R square that we have obtained, how much did predictor 1 contribute? How much did predictor 2, 3, 4, 5 contribute? That is what we mean by that. So it will help us to know the individual contributions of the predictors or the independent variable. And therefore, at the end, we can now advise as to which of them that we have to focus on, which of them we have to drop, and all those things. Now, the contribution comes in two forms, either in the form of standardized beta or unstandardized beta. So it comes in two forms, either in the form of standardized beta or unstandardized beta. Either in the form of standardized beta or unstandardized beta. Okay. We use the unstandardized beta to estimate the regression function. You will look at that. We use the unstandardized beta to estimate the regression function. To estimate the regression function. And then we use the standardized beta if you want to compare the contributions of the predictors. If you want to compare the contributions of the predictors. If we want to compare the contributions of the predictors, then we use the standardized beta. Okay? When we are done with the illustration, we will know how to compare them. We also know how to estimate the regression function. Are we okay with that?
Okay.
Okay. So these are just some of the preliminary kind of things that we have to know about the regression, multiple regression, and see how best we can now run it. So we are now going to do illustration with the multiple regression.
So that was use the standardized beta to compare
The contributions
of the
of the predictors or the predictors, contribution of the predictors or the independent variable. You know that predictors are the same as what? Yeah. Okay. So we go to the illustration and then we see.